On the rubble margins of a coral reef lives an animal about the length of a hand that holds the fastest feeding strike ever measured in the sea. It is brilliantly colored. It lives in a burrow. Fishermen in its range have long called it the thumb splitter, and almost everything famous about it, including the most repeated fact, needs careful saying. The peacock mantis shrimp, Odontodactylus scyllarus, is neither a mantis nor a shrimp. It belongs to the stomatopods, an order of several hundred species that separated from the rest of the crustaceans deep in their history and has been running its own evolutionary experiments ever since. It lives on Indo-Pacific reefs, including the Great Barrier Reef, in burrows among coral rubble, from which it watches the neighborhood with two eyes mounted on stalks that move independently. One eye tracking a passing fish, the other already looking somewhere else. The famous part sits folded under its head, a pair of raptorial limbs, each ending in a club held cocked like hammers against a latch. The strike does not work the way a punch works. No muscle contracts fast enough to produce what this animal does. Instead, the muscles load energy slowly into a spring built into the limb. A latch holds the spring at full compression, and when the latch releases, the club unfolds with the stored energy all at once. The crossbow principle rather than the throwing arm. Measured in the laboratory, the clubs reach peak speeds of 14 to 23 meters per second and accelerate at between 6,000 and 8,000 times the force of gravity. Figures the 2004 study that first recorded them compared to a small caliber bullet leaving a barrel. They do all of this through water, a medium that fights every fast thing moving in it. The water itself becomes the second weapon. The club moves so fast that the pressure behind it drops below the point where water can stay liquid, and a bubble of vapor tears open in its wake. When that cavitation bubble collapses, instants after the club lands, it delivers a second impact at nearly the same point, with a snap, a pulse of heat, and on high-speed film, a brief flash of light. The children's book version says the mantis shrimp makes the water boil and spark when it punches. The children's book version is, in its way, correct. Crabs, snails, and clams, armor that defeats almost every other predator on the reef, open like struck nuts, and the club itself, layered internally like plywood laid in spirals, survives tens of thousands of these detonations without cracking. Materials engineers study it for exactly that reason. A one-shot weapon needs a fire control system, and that is the right way to understand the mantis shrimp's other famous organ. Each compound eye carries a band of specialized rows across its middle, and the inventory inside is unmatched in the animal kingdom. Where human vision is built on 3 color channels, the mantis shrimp runs a dozen or more, several of them in the ultraviolet, plus receptors for polarized light, including circularly polarized light, a signal almost nothing else on Earth can detect, which some mantis shrimp use as a private channel on their own reflective bodies. Here is where the popular fact runs backwards. 12 channels against our 3 has been retold for years as it sees colors we cannot imagine. When researchers finally tested the animal's color discrimination behaviorally, in 2014, the result was the opposite. The mantis shrimp is worse than we are at telling close colors apart. The eye is not a connoisseur's instrument, it is a classifier. Instead of doing what our brains do, comparing a few channels carefully at computational cost, it appears to read wavelength directly against its bank of receptors, like a barcode scanner. Coarse, nearly instant, no thinking required. For an ambush hunter whose whole attack is over in under a heartbeat, a fast, rough answer about what something is beats a slow, beautiful one. The strange eye and the absurd club are one system. The eye finds and ranges, the spring delivers. A reef builds animals like this because a reef is an arms race run in bright light at close quarters. The coral architecture shelters so much armored prey that a weapon able to open armor pays for its extravagance, and the clear shallow water rewards any eye that can read it faster. The mantis shrimp is what those pressures look like after a few 100 million years of compounding. It is probably watching the camera now, in the way only it can, one eye on the lens, one eye on the exit, each seeing the scene in 12 kinds of light, none of them quite the way we would.